Hello, welcome to my talk. Let's get started. Astyanax, yeah. Astyanax, to be or not to be? That is the question. So to give you a little idea, Astyanax, if you guys are new to Cassandra, you may not know this, it's a pretty popular Java client for accessing Cassandra. So especially if you're new to Cassandra, this talk will be very helpful for you as a good starting point. Also for the veterans who've seen plenty of action with Cassandra in production, it's pretty common for them to be on Thrift. And we're also here to talk about that because Astyanax is largely a client that used to work with Thrift, at least in the past, as in only with Thrift. So there have been some changes. So this will also be very useful for you. All right, let's get started. OK, so a little bit about me. I'm Puneet. I work at Netflix at the Cloud Data Engineering Group. This is the team that runs Cassandra for Netflix in the AWS cloud. I hope you got a chance to attend talks of two of my other colleagues earlier today regarding building the big foundation at Netflix and also like the crazy active thing that we do for resiliency at global scale. So yeah, Astyanax is pretty core to that. And I am not the author of Astyanax. That credit goes to Iran Landau at Netflix. He's awesome. I'm currently the custodian of Astyanax, and I've made some pretty big contributions to Astyanax in the recent past that will really help understand the story between Thrift and CQL, Java driver, etc., which is why I'm here to talk to you about that. And oh yeah, prior to this, I worked at Amazon Web Services, a couple of distributed systems there. Funny enough, Sankalp Kohli, the Apple guy, and I were actually teammates at Apple, at Amazon before, and then we diverged, and he went and launched 75,000 nodes. Yeah, well, we didn't do that, and you know, it's okay because I'm sure your Netflix bill would be higher if we did that. So we're working pretty hard, by the way, to keep it $8. All right, some Trojan history. So show of hands, who knows who Cassandra was? All right, besides my team. All right, who was Cassandra? Oh, OK. So Hector was the brother of Cassandra, and he, or rather one of the big first Java clients that was introduced was Hector, and Astyanax was largely inspired from Hector. So that's why we call it Astyanax. Astyanax was Hector's son. OK, by the way, I want to get a feel of the crowd. How many of you are new to Cassandra, just playing with it, and not the 75,000 node guy? OK, cool. So how many of you are actively playing with Cassandra in production? Very nice. You guys will hopefully find my talk helpful. How many of you are using Java driver? OK. How many of you using Astyanax? Oh, wow, OK. Hector, anybody? Awesome. OK, cool. So I think this talk will be pretty helpful. OK, so let's get a quick introduction on Astyanax. What does it bring to the table? Just top-level features. So it's very good. It's been at use in Netflix for, I think, 2.5+ years. So it's pretty mature now. It does a very good job of load balancing, all the round-robin strategies, token-aware, all that good stuff. Connection pooling, yeah, this is actually a pretty big deal in Astyanax. It's quite mature. It's gone through a lot of patches and fixes. It's really received some good maturity now. It's been battle tested, and especially like we run this at Netflix scale in the AWS cloud. So we do see a lot of network anomalies, a lot of glitches, instances get taken away all the time, and sometimes we like to do that to ourselves with all the chaos monkeys and all. So Astyanax is pretty good that way. It's pretty resilient. It actually does help out with all this chaos. Pluggable host discovery mechanism, yeah. This is pretty easy. All I mean here is that you can supply your own mechanism, give it your seed nodes, and it'll take it from there. It'll init its connection pool. But the other cool thing is, at Netflix, we use our own discovery mechanism. And since this is totally pluggable, you can write your own. You can actually programmatically send signals to Astyanax to add or remove your host from its connection pool. We use this a lot at Netflix, especially while doing operations on nodes, like any kind of maintenance, or even if you want to isolate a node for just like debugging something. First thing we make sure is that the application traffic is routed away from that node. Now, granted that a coordinator can still send traffic to that node if it's not disabled in Thrift, but at least if you're using token-aware algorithms with CL local one, this is very useful. You don't have to actually turn off Thrift or anything on the node. You can actually just surgically route traffic away from it via Astyanax. Metrics, okay, insight. Astyanax has a lot of them. It's not just the throughput numbers of read versus write paths and latencies and stuff like that. It's also, you have a lot of insight into its connection pool, which is pretty cool. It actually can help you even debug how the connection pool is doing. As an example, if you have a fixed size connection pool, and if you have persistent connections, and you're reusing them for queries, and if your query starts slowing down for some reason, you'll actually see your connection pool saturate, and then you'll start getting timeouts. It's pretty cool. Like, you'll actually see the metrics will directly indicate that problem. It's something pretty non-trivial to debug. For an application running at large scale in the cloud, and these metrics can actually help you. And yeah, highly configurable and pluggable. So, I forgot to mention this. Astyanax was one of the big contributions for the Netflix open source software stack. So it was designed with the intent that others outside Netflix will adopt it and will plug and play. So all its components, as I mentioned, load balancing, metrics, connection pooling. If you don't like it, you can just add in your own. It's pretty configurable and pluggable. It's pretty nice. Very modular. Okay, just giving you a little idea. It uses a very nice fluent query syntax, a pretty big reason why a lot of folks use Astyanax. I hope you can actually read that slide. Apologize for the small font, but I just literally took this image from my IDE. The top line, we're just starting a mutation batch. This is a write. The second line, you can see I'm preparing a row mutation. The column family is CF time series. The row key is just CPU utilization, something I made up. And then if you can see in the for loop, I'm just inserting 30 columns for that row. That's all I'm doing. And the last line is mutation batch.execute. It's pretty simple, flows pretty well, especially if you're exploring the client in the beginning while new and figuring things out. Is pretty useful. And notice that I just did date minus 1 minute, so I'm just storing the last 30 minutes. I'm just making something up. And this is the corresponding read query. Especially wanted to show this to you. I really hope you can read that font. I can read it with you. This really shows how fluent the syntax is. It's very strongly typed. It's all Java-based. And it still brings you that fluent query syntax, which is pretty cool. So first line, you have KS, which is just a key space object. And you are preparing a query for that column family CF time series. You're asking for a certain row, CPU utilization. And then you start doing a column slice. I'm assuming you guys know what column slice is. You're just asking for a range of columns. So there's a set start, set end. I'm just asking for now minus 15 minutes. That's it. And then execute. And then below, I'm printing the columns. This code actually works. I even had the output below, but I removed it because the font looked totally weird. You wouldn't be able to read the slide otherwise. But that's it. My whole intent of showing this slide is just to prove the point of the fluent query syntax, where you can do something pretty non-trivial, and it flows pretty well, and it's a pretty compact query. Recipes, this is the big one. So Astyanax also has a lot of recipes, and I can explain what a recipe is in case you don't know it, because I didn't know it when I jumped onto the team. A recipe is just a higher level abstraction on the existing API. It's some snippet of code that does some non-trivial work for you. That's all it is. And we basically looked at certain use cases, certain patterns in the company. We're like, wow, people do this again and again. let's show them how to do it right when we can just wrap it and contribute it back to Astyanax. So that's exactly what a recipe is. These are not the only recipes. Astyanax has more of them. I don't think I have time to go through all of them, so I just listed the popular ones. Like I'll go through the first one, all rows reader. This is a recipe where it's kind of like a scatter-gather approach where you can actually ask Astyanax to read your entire Cassandra database and send all the rows back to your function call. It uses multiple threads, and it'll do a pretty good job of like looking at your token range and send one thread to each node to grab all the data, and in parallel, asynchronously, they'll bring data back to you. Now, why you'd want to read your entire database into memory is a separate conversation. It happens a lot. I've seen use cases, but it's a pretty powerful recipe. Distributed Rowlock. I think somebody else in today's summit mentioned that they're using distributed Rowlock. So this is another pretty important recipe that's being used at Netflix, where you can actually lock a row to get exclusive write access to it in Cassandra. Now, please don't confuse this with lightweight transactions. It is nowhere close. This is just an optimistic lock. That's it. But it works pretty well. And we use it for use cases where, like, if you want to send an email once and only once to a customer, you want to make sure that you don't send duplicate emails. It's basically the person has a distributed worker fleet, and they're all working on these task items, and it is possible with some distributed race condition that you could get the same task on 2 nodes, and now they're both going to send the same email to the customer, and that'll look bad. So we use this recipe to actually dedupe that. So it's pretty nice. Chunked object store. I think most of us know that storing large blobs in Cassandra is not a great idea. But at Netflix, we do have certain large blobs, like your Silverlight player that you can download from your browser when watching a Netflix movie. That is one example of a large binary file. Folks do want to store that in Cassandra because of our global replication footprint and all that stuff. They want to leverage all those features of Cassandra, but storing a large blob is not a good idea. So this is another recipe where it'll seamlessly chunk up that byte stream for you and sprinkle it all over the database. It uses unique row keys for each chunk, so you don't actually have any hotspot on any one node. So it's pretty good. And it maintains a nice abstraction for the client where you don't know the chunks, like you don't need to know. Astyanax will split it for you, and it'll also stitch it back when you do a get. So it's pretty nice. And you can control things like chunk size and all that good stuff. But this is just another example. So just wanted to give you an idea of recipes. There are more. They're available at our GitHub site, which is somewhere in this presentation, the link. So you can check it all out with a lot of examples. OK, so how does Netflix use Astyanax? Just want to give you an overall picture. If you guys can read this picture with me, like go bottom up. So look at the last row. There are a bunch of boxes there, blue boxes. Those are just the internal components. They map to some of the features I mentioned earlier, like connection pooling, load balancing, metrics, config, yada, yada. If you go up a little bit, that's the big Astyanax API right there. So this is what takes all your queries and coordinates these components below and like executes them for you in a reliable manner in the cloud. If you look at the 2 green boxes, that's also part of the Astyanax ecosystem. They're just high-level abstractions. One's a nice entity mapping layer where you can annotate your object and persist it to Cassandra via the Astyanax API. It's totally built on top of the API. And the other one is the recipes I just spoke about. And the little yellow box is all the other Netflix DALs and data access layers that we've written for all those objects that we want to store in Cassandra. And I think maybe Christos may have talked about this in the past, but we store literally everything in Cassandra at Netflix. Almost. So this is pretty key. By the way, my main, the main point I want to drive home here in this slide is that blue box in the middle where everything, ultimately, everything that's public facing goes through that front Astyanax API. And that's pretty key to remember for this presentation. You'll see how we use it later. There's no backdoor in Astyanax being used anywhere. Java driver. This is pretty key because it's now a pretty popular driver written over the SQL and native protocol. And it's in Java, so seeing very heavy adoption. So when Netflix saw this in 2013, this is pretty attractive. It has a lot of good features that we want to use, namely, to start, the first one, the Async Interface. It does use Netty underneath, so it's pretty cool. You can actually use that async feature in Java driver. And we have other projects at Netflix. I don't know if you have heard of RX Java or whatever. Like Netflix is investing a lot now in reactive extensions. So we are looking at that. In fact, our entire client server model, we want to see if that can go truly async throughout. And Netflix, by the way, has a very, very big client SOA stack. I think we have, if I'm allowed to say, I think 500 plus microservices that bring that Netflix experience to you. So that all should start going async, and this will be pretty key between client and server communication. Cursor support, this I view as the little brother of the Aldros reader. You can actually, again, do select start from table. I don't know why you would want to do that, but you can do it. It's a pretty cool feature, or not, depending on how you look at it. Collections. Collections, this is also quite powerful. It enables a lot of cool data models. A lot of people are very familiar with composite columns, and also there is some sort of parallel here with collections, especially as you're trying to map your mind to the CQL protocol. Flexible retry policies, again, another feature where, depending on your perspective, you may like it or hate it. You can actually change your consistency level on a retry. You can upgrade it or downgrade it. It does seem a little non-intuitive as to why would you want to do that, but there are a few cases where you actually can leverage that. And whatever, the other stuff in SQL. So we looked at this and we were like, wow, okay, let's start trying to leverage all of this. Can we integrate Astyanax with Java driver? Can we replace Astyanax with Java? Like, what should we do? So we started looking at our options. So by the way, just throwing this out there, like, for especially the veterans who've been using Astyanax in production, this is a pretty big deal, like, if you're going to go over Java driver. Because there's so much in Thrift that people can use to such an extent because it's so powerful, especially with the flexible schema-less design advantage of the Cassandra data model. This is quite concerning to a lot of folks. So I just want to say this, that don't worry about it. Astyanax still works over Thrift. In fact, in production today, Astyanax is using Thrift. So as long as the community supports it, we will have it. But anyways, we are pushing to integrate with Java driver, which is what I'm here to talk to you about, how we can bring the best of both worlds together. So I started a little exercise, and I pitched to the company, hey guys, you want to try using the CQL protocol, like all nice new nifty features, new things coming along. This is what they viewed me as. And the succinct technical feedback that I got from the developers was more like this, where they're like, what do you mean new features only in CQL? I'm using Thrift, what am I going to do? And then I explained all the advantages of CQL. And I actually, I can admit this, I understated the pervasive impact of Astyanax at Netflix. I did a little survey recently. I used some build system to find out there are 350 plus direct dependencies on the Astyanax library at Netflix. This is just the direct dependencies. This is not even the dependencies that pull it in via the transitive closure. This is the direct dependencies. So roughly what I was actually really saying was this, like, hey, 1,000 people, can you guys like all go refactor your code so I can bring these new features to you? Then the technical feedback was slightly different. It's a true story. It's actually not funny. Okay, anyway, sorry. But we took this feedback pretty seriously, and we went back to the drawing board, and we did understand what they were saying. When I largely speak to developers at Netflix, I find them in two categories. One is the kind of developer that will say, okay, I know what I'm doing. I know the Thrift. I know all those mutation batch queries. I also know everything about CQL, or I'll go read it up. I got it. Like, give me full control. Let me go crazy, right? And that's cool. And they can actually just directly start using Java driver if they wanted CQL. There are also, provided they understand all the data models, there is also this very large bucket of developers who are already using it in production and are worried about what's going to happen if we just flip the switch. And some of them also gave very good feedback where they're like, they don't care about the low-level petty details about which protocol has what little idiosyncrasies and how do they work with them. Some of them are asking for higher level abstractions where they don't actually care about the low-level details, which is, I think, my key point in this talk, and I'll talk to you about it more. So went back and I said, no, wait, we do have a nice new adapter at Astyanax. So remember that blue box I showed you a while back where everything goes through that front API? So what we did was we re-implemented the entire Astyanax interface to go over Java driver underneath. So Java driver is the query engine in a new version of Astyanax, which is Astyanax 2.0. And we have an adapter that can take your existing query and translate it to a Java driver query underneath. And it's totally aware of your schema. It knows what your schema is like, and hence what your SQL query should be like, which, by the way, was really a bear, but we did it. So the cool thing is your queries can now be async since they go over Netty, but they're still the same queries. Your API from the Astyanax perspective is the same. So all the recipes, the entity mapper, all got ported for free, which is good. And Astyanax still works. By the way, keep in mind, thrift is not being abandoned. We actually do have even the thrift adapter. You could use any one. You can just switch your API back and forth. Well, then there probably will be some caveats because not every data model can actually work seamlessly between thrift and CQL. Sometimes it just is not possible. But we have a nice big blog at our website, at our GitHub site, which is in this talk. And you can actually check out if your schema will work. But we basically looked at Netflix's schemas, and there are a lot of them. And I think we literally nailed almost all. So anyway, took this design, pitched it back to the devs at Netflix, and the feedback was much better. So the developers at Netflix are happier. No, it was a good lesson learned for us. So okay, very quickly doing an architectural review of what I just said. Remember that that's the blue box right there. In the middle, Astyanax API, and you have two drivers underneath. Actually, I forgot to show a little box. There's a little blue box above Java driver, which is the adapter. Or you can imagine it inside the blue box, the Astyanax API. But that's actually what translates all your queries back and forth to the Java driver. And you could, just with the flip of a switch, go back to thrift if you wanted to. Okay, yeah, the big question, what about performance? So I think the community has gone back and forth between Java driver and thrift and Astyanax and what do we do and which is faster, and there's improvements on the way, and we're talking about different technologies. I'll tell you largely what I noticed, and this is also available on our blog post, which is on our site of what we found. I don't have those graphs in here because that detail would be unnecessary at this point. But we roughly found Java driver to be on par. Or it was a little slower, but the difference was insignificant enough. Like for us, it was still a green light for production. One thing you have to remember, please use prepared statements if you're using Java driver. That is just assume that it's a requirement if you want that production performance at par. Just a little digression into prepared statements. There's actually no magic here. You prepare a query. Basically, you digest the query, create some byte buffers, send that to the server. There's some state there, and then you reuse it. So when your new queries come, your values are just dynamic values, and they just bind to that existing prepared statement. That's how it works, and that's why it's faster than not using a prepared statement. But if you look at some of the use cases that we've seen built on top of Astyanax, where people basically will go build their own data access layer on top, which can do all sorts of flexible queries, depending on the input criteria to the method. Oh, the query is going to keep changing. Imagine them trying to maintain their own prepared statement cache so they could reuse it. For some people, that may be trivial. For some people, not. People start using fancy techniques, like they'll maybe take the string query or something and they'll hash it to a value and look up their prepared statement in a concurrent hash map or something. There are other ideas to be more robust, so you're not sensitive to like weird changes in the query. And avoid collisions where you could tokenize the query and then sort those tokens and then rehash them. But whatever, it is slightly non-trivial, and you soon get into prepared statement management. So there was one cool Astyanax value add here that we discovered sort of almost after the fact. So if you look at this query in the middle, I showed a similar example before. It's keyspace dot whatever with row dot with column slice and then execute. If you notice, it's quite structured, which is kind of nice. You can view all of this as just little Java objects underneath in the Astyanax API. So the cool thing about this is all these structured queries have an innate query signature underneath. So the thing about this query signature is Astyanax can now look at that structured query and say like, I know what the prepared statement should be because I can predictably tell what the Java driver query should be. And that's right below, select star from table where key is this and column 1 is in this range. Oh yes, I said column 1. That is true. I'll tell you more about it in another slide. So anyway, the point I'm trying to drive across is that there is an innate query signature in this query. Instead of actually parsing your query to understand what its hash code should be, you've naturally done it up front in Astyanax by being forced to use a structured interface. So this is one cool thing in Astyanax where if you're using Java driver underneath, Astyanax can just understand your queries and manage the prepared statements underneath for you seamlessly. So you don't have to worry about that. And that's also how at Netflix we're going to keep that performance bar up when we switch to Java driver, which is kind of a cool thing. Anyways, a little bit more. So I think we're getting a little bit more towards Java driver and SQL now. So something else I want to show you. We started looking at the SQL protocol a little closely, and something didn't seem right. I have been asked these questions all the time, that are rows really rows, are columns rows, are rows columns, like what? And surprisingly, I know, but surprisingly, I'll be honest with you, technically the answer to all those questions is yes, depending on your perspective. I'm not joking, guys. Seriously, and I'll show it to you. I'll show you what I mean. So something was not right, and we had to fix this for Netflix because things were getting pretty confusing for the devs. So I'll give you a very simple schema, just as an example. This is a very simple example, okay? Your key type is an integer. Your column name type, which is your column comparator, is also an integer, and your values are just, say, some ASCII or some strings, right? The simplest schema possible. Take these two rows as examples. By the way, this is slightly in the old world when you're using thrift. This is the true power of Cassandra, right? The flexible schema-less design, where you have two rows, with two row keys, 1 and 2, and the first one has 5 columns, the other one has 3 columns. Great. Yeah, and these could tomorrow become wide rows or whatever, and you could do column slices and all. Cool. You guys get it. So create this using the CLI, and then log out of the CLI, log into SQL shell, and do select star from table. I hope these will be the only 2 rows, by the way. This is what you will see. I'm hoping that this is legible for you guys at the back. Note how you're seeing 8 rows here. I'll flip back to the previous slide. There are 8 columns here and 2 rows. I'll flip back again. There are 8 rows here. This is what happened for dynamic columns in CQL. Notice there's something called column 1 up there. So you see, I don't know if I can call it a transpose. It's probably not the right technical term, but that's sort of what happened to your columns. They sort of became rows. So this is kind of what I was saying. When I see this, I think of the grizzly bear that I showed earlier. Because it's not just that, hey, we're going to SQL, you can just rewrite your query with this new syntax. No, no, no. Your model is changing depending on your schema. And you have to adapt to this model. Earlier, you used to get 2 rows back, or 1 row if you asked for row key 1. Now you will get 5 rows back in your results, and you got to figure out how to, appropriately deserialize it into your object. So this is another, how do you say, this is a breaking change at Netflix, right? So the cool thing is, just to keep everybody's sanity, at Netflix, we decided to maintain the original semantics. So since we have an adapter that intercepts all your queries, it also intercepts the result sets. So it will bring your result set back to the old world, which is kind of nice because that's how I don't have my butt chewed out by 900 devs at Netflix, right? This is what we had to do to not break everybody. So this is one other cool thing. So rows in our world are still rows, and columns in our world are still columns. And by the way, this was no easy task. Like in Astyanax, we had to understand what's a row key, and then in the new way, what is a partition key, what is a clustering key, what is your primary key. So Astyanax does that by way of like describing your schema under the covers, so it exactly knows what your schema is like, and hence how to transpose your columns back. It knows that. Cool. Okay, so the takeaway, the big takeaway for the talk is that we've seen that there is a lot of value in providing higher levels of abstractions over other drivers underneath, be them Thrift or CQL. I'm just listing a few examples here, like time series is something we've been asked a million times that if somebody wants to go implement this, and I've seen various different implementations, some of them not following the best practices of Cassandra. Sliding window, like Netflix, if you play a movie and you log out, then you log back in, you want to play the movie, and it asks you, do you want to resume playing? Have you guys seen that? The way that works is every few seconds, the player is streaming heartbeats back to Netflix to show where you are in your movie experience. And that's stored in Cassandra. And the person wants to implement a sliding window over it, right? Because he doesn't want to keep everything out there for all the time. And we need data model experts to actually consult with the person to show them like how to best model this in Cassandra, how to not create hotspots, how to not have wide rows. Actually, wide row is a big problem. Like I won't take any names, but we recently had a problem where an innocent developer just ended up reading a wide row in Cassandra, is several GB, and you know what that does to the JVM, dutifully took the node down, and then did what I actually asked them to do, retry, and go to the next replica, take that replica down, and we did see a problem in production. They were sort of following best practices. No, but the large takeaway is that we're sort of leaving this window of vulnerability open for them. Like they don't know, they don't want to focus on that. They want to focus on their own high throughput service, and we're supposed to solve and make the database super resilient for them. So we have an opportunity in Astyanax to model these best practices through higher levels of abstractions. Like I actually wished at that point that I actually had a special column family which was called the wide row column family. So I could actually control how you can paginate over columns and literally introspect the bytes coming back and keep it at certain thresholds. That's very valuable for a lot of people. You don't want everybody to solve this problem again and again and again. Objects with attribute-based indexing. We've heard this all the time. Okay, I have this object. I don't know what columns are. I don't know what rows are. I need to store this object in. Oh, and I'll pull out only a few attributes at a time. We're like, okay, good, those are going to be the columns. Like, we get all of that. And then he'll say, oh, and I have these few attributes. I want to search, say it's employee or something, and I want to search by last name. And I want to get all the objects back that match this last name. And we're like, okay, he's asking for indexes. And we don't want to give that to him, because that's another thing that we say, right? Don't use indexes in Cassandra. And his feedback is like, okay, you chose this data store for me. If I don't, how do I get indexing? Whatever, inverted indexes, whatever. Give me a virtual table where this is just possible. Like, solve this problem for me, because I don't want to focus my core dev cycles on this, because they want to focus on other stuff. And that's totally legit. And that's the overall feedback we've taken. And that's kind of where we're trying to move Astyanax in that direction. So the big question, I know there is time for Q&A, and I know you guys are going to ask this, so I'll save that. What should I use? So I'll be very honest. Astyanax is all about more typed interfaces, higher levels of abstractions. If you don't want that, and if you can write SQL queries on your own, don't use Astyanax. Use Java driver. It's totally fine. It'll work pretty well. It's got all the connection pooling support, all the load balancing support. It's doing pretty well, actually, with CQL. So you don't actually need Astyanax for that. But if you do see value in higher levels of abstractions, or actually if you want to even contribute those back to Astyanax, go for it. That's actually how we want Astyanax to live on. And that's it. Question?